Okay, lesson 76, or the power of a test, is on page 728. It's got the pictures of the little girls. Power is my second favorite thing in this chapter. So, power is your ability to correctly, reject a false null and conclude the alternative. You have more power. You have more power when the alternative value in your hypothesis test. So in a hypothesis test, our alternative value is our sample value. So X bar or P hat. You have more power when X bar or P hat is very, very different from the null's value, mu or P, because the difference will be more obvious. So you will have more power when the difference is more obvious. So let me get even more specific. When we started this first unit, we started with the basketball player problem. The basketball player who claimed he makes 80% of the shots he takes. And one of the first things that we talked about was how, if we have him shoot and he only makes 40% of those shots, it's obvious to us that he's probably not an 80% shooter. That's power. That's what they mean by your sample is so far away from the claimed value that it's obvious something is wrong with your claim. So you have more power when your sample is very different from the claimed value. So let's look at a specific example with these pictures. The claim is that all of these kids are 5 years old. The alternative is that they're not 5 years old. So claim is that they're 5. Alternative is that they're not 5. Which one is most obviously not 5 years old? 1, 2, 3, or 4? 2. This example has the most power. This one, it's the most obvious that she is not 5. So she has the most power because she is definitely not 5. This age is the farthest from 5. She's the farthest from 5. She is the farthest from 5. The one that I personally think has the least power is 1. 1 is the one with the least power. This kid actually looks 5. To me, she looks 5. These two, they do not look 5 to me. So these ones, I'm sure that they're not 5. I think that they're 1 or 2. Maybe 2 or 3, actually. I think that they're 2 or 3. But it's not as obvious as the second example. So power is our ability to recognize that the alternative is true. So this one, most power, because it's the most obvious that she's not 5. Least power. None of these children are actually 5 years old. So we would reject the null each time. But our power to recognize that we should reject the null varies. Our power to recognize that varies. This is a picture of how power is related to your actual graph of your samples. So notice that your y-axis is your power. So it starts at 0 and can increase. This value here is that mu is 5. Remember, the claimed value is always in the center. So notice, as you get farther away from the claimed value of 5 years old, your power increases. So for our number 2 example, I think that she's probably like up here. If I had to graph those alternatives above, number 2 would be way over here, far away from 5. Three and 4 would still be far away from the center claimed value, just not quite as far as this one. If we were talking about our basketball player guy, what we would have in the middle is his claim of 80%. The sample value of 40% would be over here. So if we were looking at this same situation, 80% would be in the middle, 40% would be like where the max power is. It is obvious that somebody that only makes 40% of his shots probably is not an 80% shooter. Is this making a little bit of sense? Okay, so why does power matter? Why does power matter to scientists, doctors, and statisticians? Well, experiments won't be funded unless they can show that their study will have sufficient power. No one wants to pay for a study that only has a 10% chance of detecting a real difference between, say, a new drug and an old drug. So because power is so important, how can we increase power? What are some things that we can do to maximize our power? So the first one is that we could increase significance level. We could increase significance level. So remember, that's alpha. You're talking about increasing from 5% to 10%. This makes it easier to reject the null. This makes it easier to reject the null. If you increase your significance level, it's easier for your p-value to be less than that. So the disadvantage is that when you increase alpha, you are increasing the likelihood of making a type 1 error. Because remember, the probability of making a type 1 error is alpha. So if you just say, K, our significance level is 10%, you've now increased your probability of making an error from 5% to 10%. 2, I think, is the best option. Take a bigger sample. Take a bigger sample. Increasing N provides better information about your true population. So the bigger sample you take, the higher your power will be. The disadvantage to this is that it usually costs more time and money. But if we have to choose between option 1 and option 2, and we have the money to take a bigger sample or the time, we should absolutely choose option 2. Option 2 is the best. Option 3, I only include option 3 because it's in your textbook. It does not even make sense to me. Option 3 says you can increase your power by getting an alternative value farther away from the null, so it will be easier to detect there is a difference. So they're saying you want to get an alternative value that is farther from the null. So they're saying you want to get an X bar or a P hat farther away from the claim. But how do you keep your sample random if you're intentionally trying to find a value farther away? Do you get what I'm saying? Like when you start doing option 3, I don't think your results are valid anymore. Because how can you get an alternative value farther unless you start messing with your data, and you really shouldn't be doing that. But I guess it's an option. The last one is to decrease other sources of variability by using really good sampling methods. So we want to decrease variability by doing more than a simple random sample. And that's what's in the next unit. We're going to talk very specifically about simple random samples and some ones that are even better than a simple random. So one of them is a stratified sample. One is a stratified sample. The other one is a blocked experiment. So those phrases, you don't have to worry about them right now. Just know that you can design your sampling, you can design the way you get your participants in a way that minimizes your variability, and then that would increase your power. The disadvantage here is that your design becomes more complicated and ultimately more expensive than a regular SRS. So these sampling methods above are more complicated and costly than just a regular SRS. Then our last question is, or our last statement, sorry, is that it's generally accepted that you want to have at least 80% power. you want at least 80% power. So to finish this up, I am going to connect it to that little table we had from the last lesson in terms of a type 1 and a type 2 error. So across the top, we had HO true, HA true. Then down the side, we had reject, which means you conclude HA and fail to reject. If the null is true and you reject it, that is your type 1 error. We now also know that to be alpha. Type 1 error is connected to alpha. If the HA is true, but you failed to reject, that's a type 2 error. If the HO is true and we fail to reject, we're Gucci. That's exactly what we want to have happen. And now in this lesson, we have learned that if the alternative is true and you reject the null, this is power. Both of these squares are good. Both of these squares are good. These two are the errors. We want power to be greater than or equal to 80%. So our very last question shows us how to interpret power, and then just asks 2 quick questions about how power is affected. So number 1, remember power is our ability to correctly reject the null. Interpret power in context. So the setup is that P is the population proportion of girls who will like the Dallas Cowboys. Pretty sure that's the football team. Our power is 82%, which is good. How do we interpret this power? Okay, well, power is the null is true and we reject, sorry, not the null. The alternative is true and we correctly reject. So HA true, correctly reject. So if the true proportion of girls who like the Dallas Cowboys is greater than 0.58, this is HA true. There is an 82% probability that we will reject the null. So if the alternative is true, we have an 82% chance of rejecting the null, which is what we need to have happen in that case. So HA is true and we correctly reject. 2, if we change our alpha from 5 to 10, how will it affect power? Well, up here, I specifically have that. If we go from 5 to 10, your power increases. So increase. Three, if you decrease, so if you take your sample size from 87 to 21, how will it affect power? Decrease. A bigger sample size is always better. So power is our ability to correctly reject the null. So that finishes up this unit for us. You just have 3 pages to finish. And I'll get those solutions up probably today. The rest are already posted. The solutions for the rest of the check for understandings are posted. The alternative multiple choice that you can take to raise your grade will be available probably within an hour. So if you want to take that, know that that's still an option. I think that's it. Are we all good in the hood? Yeah? Okay. I'd give you